All right, so today it says using graphs and eyeballs, but really it's kind of like today's topic is just a whole bunch of random stuff that we haven't covered up until now. So we're going to be talking about inequalities. We're going to talk about parallel and perpendicular, Hoy-Vux, functions, correlation, and causation. So those are kind of the things we're going to touch on, and then we have class practice that we can work on. Okay, so first of all, the first thing I want to point out to you is this part right here where we talk about our greater than, less than, greater than or equal to, less than or equal to, okay? So remember, when I see a greater than sign, so there's a couple things that you can do to help you. I am noticing I have people that don't know what greater than and less than are. So just as a reminder, this one is less than, this one is greater than. If you can put an L above it and they're opening the same way, it's less than. See how I put an L above this one and it's not opening the same way? That means it's greater than. Okay? The other way you can think about it is if I draw like a circle right there, that looks like a G. Okay? If it looks like a G. Okay? So this one looks like an L, this one looks like a G. Whatever you need to do, you got to know which one they are. Okay? So greater than, if it's just greater than, you're going to shade above. And your line is going to be dashed. If it's less than, you're going to shade below, and your line's going to be dashed. Okay? Now, if it's greater than or equal to, you're going to shade above, but your line is going to be solid, like the or equal to. So if it's or equal to, it's a solid line. If it's or equal to, it's a solid line. So this one we're going to shade below, and our line's going to be solid, just like the inequality sign is. Okay? That's going to help us because really most of the STAR questions that they ask you, that's really what they care about. They care, do you know to shade above or below? So let me show you a couple of STAR questions so you can kind of understand what I'm talking about here. So if you look at this guy right here, okay, FYI, it's very difficult to write on this, so don't judge me or do, but just do it quietly. Okay, so for this one, it says, which inequality is best represented by this graph? This is a challenging question, okay? I'm just going to be honest with you. This is a challenging question, but the first thing I know, oh wait, there's one more thing. Sorry, go back to the notes really quick. There's one more thing I want to tell you. Okay, so if, let's put this right here. So for inequalities, if the coefficient of y, and this is if it's in standard form. In standard form, the coefficient of y is negative, we flip it, meaning we don't trust it. Okay, so let me tell you what that means. Okay, so look at this problem here. Okay, it says, which inequality is best represented by the graph? Well, first of all, I know that it's going to have a dashed line. It's got a dashed line, so that means my inequality has to be, it can't be or equal to, so it's got to be, well, let's look at which way I shade. If I put my marker on my pen on my pen on the arrow and I draw an arrow into the shaded area, I'm shading down. So it's less than. My bar is dotted, so it's not or equal to. So I can get rid of these two answers right now, right this very second. Okay? What this means is, and then if I look at y, you see how the coefficient of y is positive on all of these? I know that I can trust that less than. So all I got to do is move away and divide on these two equations. I've eliminated two. That's less work I've got to do. I would still save this one for later in the test, but it gives me less work to do. I've already eliminated f and h because of the boundary line. That's the first thing we always look at is the boundary line, because regardless of whether the sign flips, we can trust the or equal to part. We maybe can't trust the greater than or the equal to, the greater than or the less than part. We can trust the or equal to. Okay, let's look at this next one here. Okay, well, not this next one, or this next one. Hold on, we might have to look at a bunch of next ones. Hold on. I didn't mean to do that. Hold on. A bunch of next ones. Let me keep going until I find what I'm looking for. It's got to happen soon. Sorry. Okay, well, you can kind of do this one. Okay, so first of all, I know I'm going to have to convert this. I'm going to have to move and divide, right? Is the coefficient of y positive? Yes. So I know that regardless, I'm going to shade above, and I'm going to have a dashed line because it's not or equal to. So once I get this line figured out, I can graph it, and then I know I'm looking above it, okay? This one here, it says, which one is the solution set of y less than or equal to 3/4 x minus 4? Is y positive? Yes, so I can trust that. This means this looks like an L, so it's less than. It has a solid line. It's or equal to, so it's solid. So I'm looking for something shaded below and solid. Well, that's not shaded below, and it's not solid. This one is not solid, so F is the answer I want because it's solid and it's shaded below. Okay? I didn't even have to graph the line. And also, that's another thing. You notice these lines are all the same. They're not the same, but they're in the same place. So that means graphing the line is not going to help me. Okay? Let's look at this guy here. Okay? Y is positive, so I trust the sign. It doesn't have or equal to, so it's not either one of these. It doesn't look like an L, so it means I'm shading above. So it's not this one. It's got to be this one. Okay? Again, what they're wanting to know is, do I know shade above, shade below, solid, and dashed? Okay? And they're throwing other curveballs at me by asking me to convert the line, but that's what they're asking me to do. Okay? So this one, it says, this is kind of a different question, but it's got a graph. So it says she works no more than 48 hours. So no more than means not more than. It means less than. So I need to find something that's less than. Okay, well, look at that. I've eliminated B and D because they're greater than. Now just look at this one here, okay? This one stops at 48. This one keeps going. She can't work more than 48 hours, so how can this point even exist? Because she can't work there. It's not C, it's got to be A. Okay, again, we're just looking at the line and the dash. Now look at this one here. This one's a little different, okay, because this one here, the Y is not on the left side. I need Y to be on the left side, and if Y is not on the left side, all this thinking that we're about to do isn't going to work. So when I I can take the left side and I can flip the left and right side. So I could put 6y minus 54 over on the left side, and I can put minus or negative 4x on the right side. But if I flip the inequality, the sign's got to flip too. Otherwise, it doesn't stay true, because like the big side, the alligator, kill me now, the alligator is pointing at the 6y. Alligator's still got to be pointing at the 6y when I move it. Okay? Sorry. No, it says 6y. Sorry about that. We were having a conversation. Okay, and since we flipped everything, the signs didn't have to change. I'm literally just flipping everything, and as long as I flip the sign too, then it's okay. Now that I look at this, y is positive, right? So I can trust this sign. So that means it's greater than, because it doesn't look like an L. It's greater than and solid. So I'm looking for solid and above. That's not solid. I'm looking for that's not solid or above. That's not above. There it is. Again, see, once we get it in that form with y on the left, you know, it's easy. Okay, this one's even true. This one's tricky. It says 2x minus 5y equals 10 is shown on the grid. Now they say, which ordered pairs in the solution set of 2x minus 5y greater than or equal to 10? Okay, well, is y positive? No? Then we don't trust it, so we got to turn it. Now, we know the or equal to, so we know we're going to have a solid line. This is going in the same direction as an L, so that means my shading has to be down here. Now all I got to do is plot those points and see which one is in that shaded area that I just identified. Okay? So you kind of see what I'm saying there? They're asking you to know whether it's shaded or not. That's the tricky part of inequalities. Okay, I know that was a lot. Okay? So, but inequalities you're going to see a few inequality questions, so you need to make sure you know them. The second thing I want to talk about is functions. Now functions, our strategy for functions is squiggle the y. That was our, you know, it was when in doubt, table it out, and then we squiggle out the y. So like we would squiggle out this, we don't care about anything happening in that box, we don't care about anything happening in the y column, okay? Now for graphs, we look for stacked x values. So at any point we draw a line through it, if we see two x values, then it's not a function. Now, I will state for the record, I have only ever seen them ask questions on STAR that look like this. That doesn't mean that this couldn't be the first year they don't show us something that looks like this. So we want to make sure we know all the different ways something looks like a function. But remember, our strategy is to squiggle out the y. And then we look at the x. I see repeats here. This one's not a function. I see repeats here. This one's not a function. I see repeats here. This one's not a function. So that one's a function. Now, the reason we always want to check every answer is because what if it had been not? Okay? And the first answer you got was a function. Okay? So I want to be careful about that. Okay, the next thing I want to talk to you about is hoi vucks. Okay, so remember, vertical lines are vucks and horizontal lines are hoi. Most of the time, so this is an example of a question they asked about a horizontal or vertical line. So it says, which best represents this equation and its relationship to the x-axis? Okay, so this is a horizontal line. As soon as I see a horizontal line, I write HOY equals. Okay, and now I'm going to look at my answer choices. Okay, so I know it's horizontal. I know it's got 0 slope. I know it's a y equals. So now I'm looking at these answer choices. Wait, they've got x equals here. That can't be right. So A and B are out. Now it's talking about how it relates to the x-axis. Well, is it parallel or perpendicular to the x-axis? Well, those two are parallel. So it's not those two. The only one I haven't crossed something out on is C. Okay? Let's look at this one right here. Another example of a star question where they you know, asking you about horizontal and vertical. So this is, what are the equations, slope of the line shown on the grid? Well, this one is vertical. It's a V, U, X equals, right? So first of all, I'm going to look for X equals. Well, this one says Y equals. These two say Y equals, so they're not what I'm looking for. Okay? The U in VUC stands for undefined. So the answer is X. I mean, J. The answer is J, okay? So again, that's what hoi vucks helps us with. It helps us like kind of narrow our focus. I see vucks, I'm looking for vertical lines. I'm looking for the word undefined. I'm looking for x equals equations. If they give me a table, okay, I'm looking for 6, 5, 6, 8, 6, negative 12. I'm looking for all the x's to be the same. They give me ordered pairs. I want all the x's to be the same. That's what I'm looking for when I see a vertical line. When I see a horizontal line, I want all the y's to be the same. I want to see horizontal. I want to see 0 slope. I want to see y equals. Okay. I want to talk about, real quick, I want to talk about correlation and causation. Okay. When we talk about correlation and causation, this is what I want you to keep in mind. When it says causation, one must affect, is it affect or effect? I'm going to say effect, and I don't think that's right, but effect the other. Emphasis on the word must. Okay, so if the student population at a school increases, must the number of teachers at the school increase? Spoiler, the answer is yes, because actually every year at our school, if we have less students, so for example, if we have less 6th graders coming in next year, we're going to need less 6th grade teachers. We're going to have less allocations for teachers. So this is true. Okay. When the amount of sugar in a quart of apple juice is reduced, there are fewer calories in each serving. So if I have more sugar or less sugar, must there be less calories? Yeah. When there are more workers on a project, will it be completed in less time? Yeah. When there's more protein in a diet, does that mean they're going to score more points in a game? No. So what's the answer? The answer is D, even though I circled A, B, and C. So what do you think the most often picked wrong answer was on this question? It was A, because they saw one that was causation and stopped, and they forgot that the word not was there. This right here is why I'm always telling you to check every answer choice, because this is the question that I'm always going to miss. Okay, here's another example of causation. If a rectangle is longer, does it have to be wider? No. If a cell phone is used more, is it going to use more battery? Yeah. If you eat more ice cream bars, do you have to drink more milkshakes? No. If you have more soccer balls, does that mean you're going to win? No. Okay? So again, with those, you're thinking must. It's a requirement. One is going to affect the other, whether you want it to or not. Okay, the last thing I want to talk to you about is parallel and perpendicular. We're going to make a little section here, and this is like literally the best I could think of. Okay? So parallel. Okay, when you see parallel, this symbol right here is literally, this two L's, that is literally the symbol in geometry for parallel lines. That is literally the symbol. So this means, and when you see these parallel lines, they're running together. They're the same. That means they have the same slope. Okay, same. Okay, whatever, don't judge me, or do. Okay, when you see perpendicular, I want you to think perpendifferent. Okay, I know it's dumb, but go with it. Perpendicular, perpendifferent. That means with parallel, the slope's the same. With perpendifferent, the slope is different. And I've got these two F's in the middle of perpendifferent. One means flip the sign. The other means flip the fraction. Okay, so when I see parallel, the slope should be exactly the same. Parallel and perpendicular are all about the slope. The slope is the same for parallel, the slope is different for perpendicular. How is it different? I got to flip the sign and flip the fraction. So let's flip on back. And we did these questions a while back. This is like page 29, okay? So on page 29 back here, it says, what is the equation in slope-intercept form of the line that crosses the x-axis at 36 and is perpendicular? So I'm going to circle crosses the x-axis at 36 and is perpendicular. And I'm going to write different, and I'm going to circle the two F's because that means I got to make two changes to this slope. Okay, the slope is negative 4 over 9, negative 4 ninths. So first thing I'm going to do is I'm going to flip the fraction. That becomes 9 over 4. Then I'm going to flip the sign, positive 9 over 4. Well, that eliminated two answers for me immediately. F and G are gone. Now all I got to do is put these two equations in y1 and see which one crosses at 36. So that would be 36, 0. I will be looking for a 0 of 36. Okay? Same thing here. Let's look at this guy right here. Okay? What is the equation in slope-intercept form of the line that passes through the point 2, negative 2, and is perpendicular to the line represented by 2/5 x plus 2? Well, it's different. And it's different in two ways. So I take my 2/5, I flip it, becomes 5 over 2. I flip its sign, so instead of being positive, it's negative. And then I eliminate two answers right away. And then all I got to do is put these in the calculator and see which one goes through 2, negative 2. Now, lest you think it's always that convoluted, let's look at this one. This one says, what's the equation slope-intercept form of the line that passes through the point 50? Again, that's important. And is parallel to the line represented by 1.2x plus 3.8. Well, those two lines are going to the same place. They're going to the same place. I have the same slope. So the 1.2 should still be 1.2. I've still eliminated two answers, and then all I got to do is put the other two in and find out which one goes to the point 50. Don't let this trick you. Just because it has a 5 in it doesn't mean it goes through 50. That means it goes through 0, 5. It might still go through 50. Spoiler, it doesn't. But you got to check it. Okay? So that's kind of all. This is like an odds and ends day. All right? Again, we're just looking at kind of like the leftover stuff. And then right here, they've only ever asked about systems of inequalities once. But remember, when I look for systems of inequalities, I'm looking for where both of the inequalities are true. So this one is true here, that one's true there, and this area right here is where the system is true. Okay? I hope that was helpful. Again, it's like a whole lot of odds and ends and random little pieces, but make sure you study it.